So case 1, HA is mu less than mu 0. The p-value would be whatever the left side is t. Okay, and you have to use t table. Okay, t curve. All right, with degree of freedom and -1. Don't use normal curve. All right. Case 2. So the left side plus right side should be 1 because the total area under the t curve is 1. Okay. Alright. Why is this situation? P-value is this. Okay. Alright. Let's go to next page. Two sample, two sample for means. Okay, mu1, mu2. So you can find 95% common interval of mu1 minus mu2, which is just what? Just x1 bar minus x2 bar plus minus t star. Keep in mind, not 1.96, okay? Standard error. S1 square over n1 plus S2 square over n2, and degree of freedom is equal to, remember this very complicated formula? That is A plus B squared over A squared over n1 minus 1 plus B squared over n2 minus 1. Well, here A equals S1 squared over n1, B equals S2 squared over n2. So run the DF down to a whole number. Okay, T star should be found using the T table. Let's find test of hypothesis. Okay, so H naught is mu1 equals mu2 because you are comparing two means. HA is mu1, well, less than mu2, or greater than or not equal. 3 possibilities, always. Okay. The T statistic value. T equals x1 bar minus x2 bar divided by, that's easy, A plus B. Okay, so this is just A, this is just B. Okay, now the p-value, okay, case 1, HA is mu1 less than mu2. So I'm going to draw the curve right here. Okay, you don't need to draw the curve a few times. This is T. Keep in mind, if your T is negative, you gotta use symmetry. Okay. The p-value is the left side. Okay, but keep in mind the t-table is, give you the right side, okay? But if you have negative t, okay, negative t is here, something like negative. If you have negative value right here, because the center is 0, okay? So in this situation, you gotta be using the symmetry, alright? You have to use symmetry, alright? So left side is the p-value. Case 2, HA, mu1 greater than mu2. Then the right side is the p-value. Case 3, HA, mu1 not equal to mu2. So the p-value is twice of the smaller side. Okay, good. Now we talk about chi-square, okay? Chi-square test for goodness of fate. So you are gonna have assumed, usually your H0 is something like that. So like P1 equals something, P2 equals something, and so on. P3 equals something, okay? And your HA usually is at least one is wrong. Okay, that means P1 is not equal to something, or P2 is not equal to something. Okay, and so on. So you have to calculate expected. Okay, expected counts. Right. So expected counts equals like E1 equals the total times P1, and E2 equals the total times P2, and so on. Whatever K equals N times PK, if you have K category, okay? Then you have your data O1, O2, OK. You have E1, E2, EK, right? Then you find, the difference, the chi-square would be O1 minus E1 square over E1 plus, keep doing the same thing, EK, OK minus EK square, alright? You only have one chi-square, which is the sum of all the K terms. So the p-value, okay, oh yes, the degree of freedom, degree of freedom equals K minus 1, okay? Degree of freedom. So p-value is, you can use the chi-square curve. Always the right side. This is always the p-value, okay? So this is your chi-square statistic value. You can use chi-square table to find the right side. This is the only p-value. Never the p-value is the left side. You will never multiply the smaller region by 2. So p-value is always the right side for chi-square. All right. Next, we talk about chi-square test for independence. Okay, chi-square test for two-way table, continuously tables, okay? So you have this kind of table, right? So you observe some like O1, O2, O3, O4, O5, O6, O7, O8, O9. Just give you an example, okay? The table may be, this is 3 by 3 table. You may have 2 by 4, 2 by 2, 3 by 2, 4 by 3, many kinds. So you gotta, find the total. So this is the total. I'm gonna call it, what about call it, I really don't know what is the total. I'm gonna use T1, T2, T3, okay? This is, I don't know, let me use R1, R2, R3. Well, this little corner is the grand total. Grand total is all these O added together. So you had to find E1, E2, E3, E4, E5, E6, E7, E8, E9. These are called expected values, okay? Expected or expected counts, whatever. So like E1 is equal to T1 times R1 divided by grand total, and E2 equals T1 times R2 divided by N. So look, if you find E2, you gotta use the row total, which is here, and the column total, which is here. Okay? And keep doing this until you find all these E's. Then finally, your chi-square statistic value is O1 minus E1 square over E1 plus, keep doing that, okay, for all pairs of O and E. Then finally the p-value is calculated as before, but degree of freedom is the number of rows minus 1 times number of columns minus 1. Okay, that's the degree of freedom. Then you can use the chi-square table to find the p-value, which is always the right side. And if your p-value is less than 0.05, you reject H0. But what is our H0? Oh, I haven't given H0. H0 is the row and column variables. Okay, variables are independent. Okay, independent. Or no association. Same thing. And HA is, not independent. Okay, not independent. Or there is association. Okay, give one H0, HA is there. All right. So so for when we're over, you have to know MSG, MSE, and based on homework, example, we can find the formula. All right, good luck.